This is a walkthrough of problem 2 on practice exam 1 of module 9 in the book Problem Solving Guide for Mechanics and Thermodynamics. We have a long plain vinyl record, diameter of 11.9 inches, designed to be played at 33.3 revolutions per minute. When the phonograph needle is 2.5 inches from the axis of rotation, calculate the speed at which the record is going underneath the needle. When it's 5 inches from the center of the record, near the end, calculate the speed at which the record is moving underneath the needle. What is the period of revolution of the record? And D, how does the record player know how fast to play the music? It's moving a lot faster when it's near the outside. For an object that's purely rotating, the speed of any point on it is omega r, where omega is the angular speed, r is the distance from the axis of rotation. Omega must have units of radians in the numerator, because that's a natural unit of angle. So we have to convert that to radians. So 33 1/3 revolutions times 2 pi radians per 1 revolution is 209 radians. So the angular speed of the record, which is 33.3 revolutions per minute, is also 209 radians per minute. So omega 209 radians per minute times 2.5 inches, that's omega r, that's the speed, 523 inches per minute. How fast is that? It's hard to tell. I'm not used to that unit. Let's convert it to inches per second. So it's 8.7 inches per second. Pretty slow. For part B, you're twice as far away. It's omega r. R is doubled. Omega is the same. The speed's doubled. So 17.4 inches per second for part B. Part C, we need the time to go around once. The period of revolution. Okay, how much time does it take to go around once? 33 1/3 RPM is 33 1/3 divided by 60 revolutions per second, which is 0.55, a little bit more than a half, right? 0.555 rotations per second. The period is the inverse of this. Seconds per rotation, 1.8 seconds. That's the period. Part D is probably what you think. The music is just recorded farther apart near the edge of the record. For you youngsters, when you play a record, you put the needle at the end and it goes in. It follows a single groove as it spirals in towards the center. All of the sounds of the music are encoded in the grooves. The jiggly path that the needle makes through the grooves reproduces the music in the speaker, all of it. Here's an electron micrograph of adjacent grooves. It's hard to wrap your head around what's going on here. These are the flat spaces. It looks like an optical illusion. You have to make sure these are the troughs. These are the troughs, and these are the flat spaces in the record. I guess there's just one groove. It's a spiral groove. As the needle vibrates through this groove at, 8, 10, 15 inches per second, the jiggles encode all of the sound. The voice, the timbals, the violin, the drums, everything is all encoded in these little lines. As the old guys say, groovy. That's problem 2.